When composing music, several techniques are used to create depth, complexity, and emotion in a piece. Here's an overview of some key techniques. 1. Melody. Definition. The melody is the main theme or tune of the song. It's typically the most memorable part and is often what people hum or sing along to. Techniques. Melodies are created using scales and modes and can be simple or complex depending on the desired effect. They often repeat with variations to maintain listener interest. 2. Harmony. Definition. Harmony refers to the combination of different musical notes played or sung simultaneously to support the melody. Techniques. Harmonies can be created using chords, a group of notes played together. Chord progressions, or a sequence of chords, can evoke different emotions. For example, a major chord progression tends to sound happy, while a minor chord progression might sound sad. 3. Counterpoint. Countermelody. Definition. Counterpoint involves the interplay of two or more independent melodies that harmonize with each other. Techniques. In counterpoint, each melody is distinct but complements the other. This technique is common in classical music and involves careful consideration of how the melodies interact rhythmically and harmonically. 4. Rhythm. Definition. Rhythm is the pattern of beats or a sequence of durations of notes and silences in music. Techniques. Rhythmic techniques include syncopation, placing emphasis on usually weak beats, polyrhythms, two or more contrasting rhythms played simultaneously, and time signatures that dictate the beat structure, e.g., 4/4, 3/4. 5. Texture. Definition. Texture refers to how many layers of sound are heard simultaneously and how they interact. Techniques. Monophonic, a single melody without accompaniment. Homophonic, a primary melody supported by chords. Polyphonic, multiple independent melodies played simultaneously. Heterophonic, a single melody played by multiple instruments or voices, each with slight variations. Number 6. Dynamics. Definition. Dynamics involve the volume of the music and how it changes throughout a piece. Techniques. Crescendo, gradually increasing the volume. Decrescendo, or diminuendo, gradually decreasing the volume. Piano, soft. F, loud. Mezzopiano, and mezzoforte, MF, moderately soft or moderately loud. 7. Timbre. Definition. Timbre refers to the unique quality or color of a sound that distinguishes one instrument or voice from another. Techniques. Composers choose different instruments or vocal techniques to create the desired mood. For instance, a flute might convey a light, airy feeling, while a cello might evoke a rich, warm tone. Definition. Definition. Form is the structure of a piece of music, or how it's organized. Common forms include binary, AB, two contrasting sections. Ternary, a three-part form with a return to the initial section. Sonata form, common in classical music, involving an exposition, development, and recapitulation. Verse-chorus form, typical in pop music, alternating between verses and a repeating chorus. 9. Orchestration and arrangement. Definition. Orchestration is the assignment of different parts of the music to different instruments. Arrangement involves organizing and structuring the various elements of a composition. Techniques. Effective orchestration and arrangement take into account the range, timbre, and capabilities of each instrument to enhance the overall sound. 10. Modulation. Definition. Modulation is the change of key within a piece. Techniques. Modulation can create a shift in mood or increase the intensity of the music. Common modulations include moving to the dominant key, a fifth above the original key, or relative minor major. 11. Motif and leitmotif. A motif is a short musical idea or pattern that recurs throughout a piece. A leitmotif is a recurring motif associated with a particular character, idea, or emotion. Techniques. These are used to create thematic coherence in music, especially in operas, film scores, and symphonic works. 12. Syncopation. Definition. Syncopation involves placing emphasis on normally unaccented beats or between beats. Techniques. This technique is common in jazz, rock, and pop music, creating a sense of surprise or rhythmic complexity. These techniques can be combined and layered in various ways to produce complex and emotionally engaging compositions. The art of composing lies in balancing these elements to create a piece that resonates with listeners. What is a pitch? Pitch is simply how high or low a sound is. Think of a piano. The keys on the right side make high sounds, high pitch, and the keys on the left side make low sounds, low pitch. What is a key? A key in music is like a home base for a song. It's a group of notes that sound good together. When we say a song is in C major or D major, we're talking about which set of notes, or key, the song is using. What is a scale? A scale is a specific set of notes in order, either going up, getting higher, or going down, getting lower. Each scale has its own unique sound. C major scale is a set of notes that starts with C and follows a specific pattern. Notes C, D, E, F, G, A, B, C. All these notes are the white keys on a piano. D major scale. The D major scale is a set of notes that starts with D. Notes D, E, F sharp, G, A, B, C sharp. It's similar to the C major scale, but starts on D and has two sharp notes, C sharp. What's the difference? C major and D major are different keys with different starting points and notes. C major uses only the white keys on the piano, while D major uses a mix of white and black keys. They give a different feeling or mood to the music because of these differences. What is pitch change modulation? Pitch change or modulation means moving from one key, like C major, to another key, like D major, in the middle of a song. Imagine you're singing a song and you start in C major, comfortable range. Then you switch to D major, slightly higher range. This shift gives the song a fresh feeling. Why does this matter? Changing the key pitch makes the music more interesting and can evoke different emotions. For example, going from a lower pitch, C major, to a higher pitch, D major, can make the music feel more exciting or uplifting. In simple terms, C major and D major are like different settings on your musical sound dial, and changing the pitch is like turning that dial to make the music feel different. Using mathematical patterns like the Fibonacci sequence and the golden ratio to develop or improve music is a fascinating and advanced compositional technique. These patterns can influence various aspects of music, such as rhythm, melody, harmony, and structure, creating pieces that are aesthetically pleasing and naturally balanced. Here's a detailed explanation of how these techniques can be applied. 1. Fibonacci sequence in music. What is the Fibonacci sequence? The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones, 0, 1, 1, 2, 3, 5, 13, 21, etc. Application in music. Melodic development. You can create melodies where the number of notes or the intervals between notes follow the Fibonacci sequence. For instance, a melody might have phrases of 1, 2, 3, 5, and 8 notes. Rhythm. Rhythmic patterns can be based on the Fibonacci sequence. For example, a rhythm could have measures with lengths of 1, 2, 3, 5, and 8 beats. Form and structure. The overall structure of a piece can follow Fibonacci numbers. For instance, the sections of a piece might be 5, 8, 13, and 21 measures long, creating a naturally expanding form. 2. Golden ratio in music. What is the golden ratio? The golden ratio, approximately 1.618, is a proportion that is often found in nature and is aesthetically pleasing. In music, it can be used to determine the relative lengths of different sections. Application in music. Form and structure. Divide a piece into sections using the golden ratio. For example, if a piece is 100 measures long, the transition or climax might occur at the 60-second measure, 100, 1.618, 62. Phrasing. Individual phrases or motifs can be proportioned using the golden ratio. A phrase might be 8 measures long, with a significant change or climax occurring at the 5th measure, 8, 1.618, 5. Dynamic shaping. The rise and fall of dynamics, loudness, in a piece can be shaped according to the golden ratio, creating a naturally flowing crescendo and decrescendo. 3. Fractals in music. What are fractals? Fractals are complex patterns that look similar at any scale and are often self-similar. In music, this concept can be applied to create intricate, repetitive structures. Application in music. Rhythmic patterns create rhythms that repeat in a self-similar way at different levels, producing a fractal-like structure. For example, a rhythmic pattern might repeat every measure, with each repetition containing a smaller version of the same pattern. Melodic sequences. Melodies can be constructed to have self-similar patterns. A melody might repeat in a higher or lower octave, or with variations that mimic the original motif on a smaller scale. Form. Entire sections of music can be designed to mirror smaller sections, creating a fractal-like overall structure. Symmetry and palindromes in music. What is symmetry in music? Symmetry involves creating music that is identical or similar when played forward and backward. Application in music. Palindromic structures. Compose melodies, rhythms, or entire sections that are the same forwards and backwards, like a palindrome. This can create a sense of balance and closure. Reflective patterns. Use symmetrical intervals or rhythms where the second half of a phrase mirrors the first half, either exactly or with variations. 5. Prime numbers in music. What are prime numbers? Prime numbers are numbers greater than 1 that have no divisors other than 1 and themselves, e.g. 2, 3, 5, 7, 11, etc. Application in music. Rhythmic structures. Use prime numbers to determine the length of phrases, measures, or rhythms. For example, a piece might have phrases of 3, 5, 7, and 11 measures. Melodic intervals. Construct melodies using intervals based on prime numbers, which can create unusual and interesting harmonic relationships. Serialism. In serialist music, prime numbers can be used to organize the sequence of notes or the transformation of motifs. Number 6. Chaos theory and nonlinear dynamics. What is chaos theory? Chaos theory explores how small changes in initial conditions can lead to vastly different outcomes. In music, this can lead to compositions that are complex and unpredictable. Application in music. Algorithmic composition. Use computer algorithms based on chaotic equations to generate music. This can produce highly complex and seemingly random structures that still have an underlying order. Improvisation. Musicians can improvise based on chaotic patterns, creating performances that are unique and difficult to predict. 7. Polyrhythms and complex time signatures. What are polyrhythms? Polyrhythms involve 2 or more conflicting rhythms played simultaneously, often based on different subdivisions of the beat. Application in music. Complex rhythms. Create polyrhythms by layering rhythms with different time signatures, such as 3/4 over 4/4. This can add complexity and drive to a piece. Cross rhythms. Explore cross rhythms, where the emphasis of the rhythm shifts across the bar lines, creating a sense of movement and tension. 8. Spectral music and Fourier transforms. What is spectral music? Spectral music focuses on the analysis and manipulation of sound spectra, the distribution of energy over frequencies, to create new timbres and harmonic structures. Application in music harmonic analysis. Use Fourier transforms to analyze the harmonic content of a sound and then reconstruct it with alterations, creating unique timbres and harmonies. Microtonal composition. Employ microtonal intervals derived from spectral analysis to create music that moves beyond traditional Western tuning systems. 9. Use of mathematical ratios. What are mathematical ratios? Ratios like 2-1, octave, 3-2, perfect fifth, and 4-3, perfect fourth, have been used since ancient times to create consonant intervals. More complex ratios can generate more dissonant or unique sounds. Application in music. Interval construction. Build melodies and harmonies using these ratios to create specific emotional effects. For example, using the ratio 3-2 repeatedly in different contexts can produce a coherent yet varied harmonic texture. Tuning systems. Explore alternative tuning systems like just intonation or equal temperament, which are based on mathematical ratios to create music with distinct tonal qualities. 10. Algorithmic composition. What is algorithmic composition? This involves using algorithms, sets of rules or instructions, to generate music. Algorithms can be based on mathematical patterns, random processes, or rules derived from music theory. Application in music. Procedural generation. Use algorithms to generate music automatically, which can be refined or used as a starting point for further composition. Mathematical models. Apply mathematical models such as fractals, cellular automata, or L systems to create complex, evolving musical patterns. Summary. These techniques allow composers to harness the inherent beauty and complexity of mathematical structures, creating music that feels both naturally balanced and intellectually stimulating. By applying these advanced concepts, you can explore new ways of thinking about composition, leading to innovative and unique musical works.